Assalamualaikum. Today we're going to talk about volumetric analysis, or also known as titration. Volumetric analysis is measure volume of reagent needed to react with analyte. Meanwhile, volumetric titration is the add increments of reagent to a solution of an analyte until the reaction is complete. Common titration divided into four. First, oxidation reduction. Second, acid-base. Third, complex formation. And lastly, precipitation reaction. Next, we're moving on to concept of volumetric analysis. First, the reactant will react with standard solution from burette, a known concentration called titrant. The analyte in which the concentration to be determined is placed in a conical flask. Lastly, the appropriate indicator will add into conical flask to determine the endpoint, shown by the color changing of the indicator. As you can see, titration have 5 requirements in this slide. First, there should be no side reaction. Second, there should be an obvious change in solution properties when the reaction has complete. Next, we have the reaction should be quantitative, and the reaction should be also stoichiometric. Lastly, the endpoint must be equal to the equivalent point. To succeed the process, we must have the equipment. For titration, we must have burette, rated stand, conical flask, distilled water, and volumetric flask.
I will explain the theory of volumetric analysis. Volumetric analysis is commonly referred as titrimetric analysis. Volumetric analysis is the method which the concentration of a substance in solution is estimated by adding the same number of compounds of another substance present in solution of known concentration. There are 4 principles of volumetric analysis. The first one is an unknown number of chemical substances that need to be examined must be present in the solution. The second one, reagent with unknown concentration should react with the chemical substance of unknown amount in the presence of an indicator, phenolphthalein, to show the endpoint. The third one, the volume are measured by titration which complete the reaction between the solution and reagent. And the last one is the volume and concentration of reagent which are used in the titration show the amount of reagent and the solution.
For the methodology of volumetric analysis, it contains 6 steps. First, record initial reading of solution in the burette. Second, turn the tap to start pouring out liquid of the burette into the conical flask. Then, the flask is swirled continuously. Third, slow the adding of solution when indicator begins to change color. Next is, stop the flow when there is a permanent color change. Then, record the final volume. And for the last one, repeat the titration until concordant values are obtained. The calculation used for this experiment is initial reading minus final reading. This is the example of result between hydrochloric acid and sodium hydroxide. Phenolphthalein indicator are used in this experiment. As we can see, the color of solution changes from clear to pale pink color.
Next, we move to the titration curve. What is the meaning of titration curve? Titration curve is the plot of CH of the analyte solution versus volume of the titrant added as an titration progresses. Titration curve has 2 types. Firstly, titration curve for a strong acid HCl with the strong base NaOH, and the second is titration curve for a strong base NaOH with the strong acid HCl. When we add the solution of NaOH into the solution of HCl, the pH will progressively increase. This is what we call as the titration curve for a strong acid with a strong base. Before the addition of NaOH solution into the HCl, the pH HCl has acid is 1, and after the addition of NaOH solution, the pH will increase slowly. Every titration curve has an equivalence point. What is the meaning of equivalence point? Equivalence point is the points which equimolar amounts of acid and base that have reacted. Beyond the equivalence point, the pH will increase slowly. Next, we move to the titration curve for strong base and strong acid. When we titrate base with the continuous addition of HCl, the curve obtained is exactly reversed. The pH will decrease at the beginning, and near the equivalence point, there will sudden fall through pH 7 as the concentration of H plus ions increases sharply.
So next, we move to the concept of back titration. As we know that back titration is a titration done in reverse. Instead of detitration of the original sample, new excess of standard reagent is added to the solution and the excess is titrated. So when this back titration is often used? It's often used when the solution being titrated is too weak or too slow to give a reaction. The second one is the endpoint of the normal titration methods is difficult to determine, and it's also used for some precipitation titration. And you must know that this back titration should be used when necessary only.
So guys, what do you think about the advantages of back titration? They have two advantages of back titration, which is the endpoint of reverse titration is easier to identify than the endpoint of normal titration. For the second one is it's useful for trying to work out the amount of an acid or base in a soluble solid. Next, we continue with the disadvantages of back titration. So guys, what do you know about disadvantages of back titration? So let me explain. For the first one, you need to skill and practice to get the effective result. For the second one, is time consuming is done manually. For the third one, instrument have to be properly calibrated since it will give effects for the final result. For the last but not least, reactivity of the element to be titrated should be well researched since they may affect for the endpoint.
In cosmetic industry, volumetric analysis is commonly used during the production of products. The first one is concentration and amount of ingredients. Volumetric analysis is used to determine the concentration and amount of ingredients used in cosmetic. Certain substances can be measured using this technique such as preservative, parabens, thickener, or active ingredients like retinol and benzoyl peroxide. This technique is important because it will determine the product doesn't cause any harm to the consumers. The second one is contaminant detection. This technique is used during the production of product to guarantee the safety and consistency from batch to batch. Manufacturers carefully making sure that the product in each batch fulfill the required criteria and prevent any substance like mercury contaminate their products. In finished product, it is therefore not uncommon to find impurities from the raw material of which it is composed.
Next, the application in food industry. They have two determinations, which is determination of acidity and determination of particle in food. For acidity, volumetric analysis is a method to measure the acid or base contained in different food items. It also can use to measure the salt content in canned vegetables using manual titration, and it's also manufacturing of drinks such as wine, fruit juice, and vinegar. For determination of particle food, titration can be used to measure the peroxide value in fats or oil. Use titration to calculate the precise amount of salt in a particular foodstuff. And it also used to determine the concentration of vitamin C and vitamin E additive in foods.
Next, let's take a look at pharmaceutical. First, dissolution testing. Dissolution testing is conducted to evaluate the release of drug substance from solid dosage form. Titration can be employed to measure the concentration of the drug released from the dosage form over time. This information helps assess the drug availability and its dilution characteristic. This information helps assess the drug's availability and its dissolution characteristic. Next, we have assay determination. Titration is used to determine the potency or concentration of active pharmaceutical ingredient in drug formulation. By reading the analyte with a suitable titrant, the endpoint of reaction is determined, thus allowing for the calculation of the API concentration. Lastly, impurity determination. Titration is used to detect and quantify impurities in pharmaceutical samples. Impurities may include dehydration products, residual solvent, or unwanted byproducts. By selectively reacting the impurity with a specific titrant, its concentration can be determined, ensuring compliance with regular limits.
Next is wastewater management. First is alkalinity and acidity. It can affect biological processes and decrease their ability to buffer. Apart from that, more neutralizing agent is required to counteract an increase in alkalinity and acidity. Thus, acid-base titration can be used to determine alkalinity and acidity and to make necessary adjustments. Second is pH control. pH control is an important parameter in wastewater treatment. By titrating wastewater with a standard base and acid solution, the rules of volumetric analysis for this treatment can be known, which it can be used to measure and adjust the pH of wastewater.
Volumetric analysis play a significant role in determining the amount of unknown substance present and its use in numerous industries like wine industry, food industry, cosmetic industry, and pharmaceutical industry. Titration plays a crucial role in laboratories in determining the correct and aesthetic dosage during an operation. Titration also helps to check blood sugar levels, look for other diseases, figure out the outcomes of pregnancy tests, and in different types of urine testing. Titration also have to describe the amounts of saturated and unsaturated fatty acids in food, the length of the change, the concentrations of salt and sugar, and the vitamin contents in food. Moreover, titration helps describe when wine and cheese have finished ripening and is ready for consumption.